I'm going to go over the 2.4 quick check kind of quickly. So the first little thing was to find the molar mass for C2H6O. Well, that we've actually done in some of our earlier lessons, so let's just do it. First off, we take this compound and we break it down. We have 2 carbons, and we have 6 hydrogens, and we have 1 oxygen. And looking up on the periodic table, that's going to be 2 times 12.01 AMUs, 6 times 1.008 AMUs, and 1 times 16.00 AMUs. So that is going to be 24.02 AMUs, 6.048, and 16.00. Add that all together, this is going to be 680, 4, and that's 10, plus 6, 6 carry the 1, 46. Now, if we were to say, okay, this is 46.068 AMUs, atomic mass units, then we would be talking about 1 molecule of dimethyl ether. But what we're really going to do, we're going to say this is grams, and that grams is 1 mole. Okay, so it's the molecular weight written in grams, called the gram molecular weight. Actually, gram molecular mass. And that name is really useful, except it's too long, so we just take the word mole out of that. So 1 mole is 46.068 grams. So now we have some mole facts about this chemical. 1 mole of C2H6O is 6.02 times 10 to the 23 molecules. 1 mole is 46.068 grams, and 1 mole is 22.4 liters at STP. Now again, this number is always, always, always good. We can use that for anything. This one is only good for C2H6O, but we can calculate this number for any substance we want to. 22.4, that only works for gases at STP. So let's look at our mole map. So our mole map, we could go through and say we could start with moles, okay? We could change to grams, and sometimes we could say, you know, in a problem, they would say calculate the mass, and we'd have to know that's grams. Or we could say go to molecules, or we could say change it to liters, and again there, the clue word might be volume, calculate the volume. So in our mole map, if we wanted to go between moles and molecules, we would use 6.02 times 10 to 23 molecules for 1 mole, Avogadro's number. Or we would take that number and flip it over, 1 mole over 6.02 times 10 to 23 molecules. To go to grams from moles, we would use 46.068 grams per 1 mole, or again, we could flip that over and say 1 mole is 46.068 grams. And if we want to go to liters, and we're talking about a gas at STP, 22.4 liters per mole, or 1 mole is 22.4 liters. We can use that either way. So this is our mole map. So if we have a problem, let's say we start with grams, then we can always change to moles, but we might want to go to volume. So if we did, that would take 2 conversion factors. If we wanted to go from molecules to grams, that would take 2 conversion factors. If we just want to go from molecules to moles or moles to molecules, that would take 1 conversion factor. So this mole map kind of helps us visualize what the problem's going to look like. So let's try a few of these. Find the mass, that means grams, of 0.621 moles of C2H6O. So we have to find our starting number, so 0.621 moles. And we're going to say 1 mole. Now we say, well, what can I use to get to grams? So if we go back here, this mole fact here will get us to grams. So we want to use our 46.068 grams. And we're just going to multiply those 2. And when I do that, I get 28.6 grams of C2H6O. Okay, let's try the next one. It says volume and molecules. Volume and molecules. So that means I'm going to start here in volume, and I want to get to molecules. That's going to take me 2 steps. Let's go back and try it. So there's my given number. Here's my starting number. So 5.95 times 10 to the 24 molecules. And there's no shortcut for the word molecules, too bad. Okay, so this here, I need molecules on the bottom. Well, my only conversion factor that has molecules, the only mole fact, is 6.02 times 10 to the 23 molecules in 1 mole. Now I need, this one's going to have 1 mole because I know I'm not done because I need to try to get to volume, which is liters. And liters, that must be 22.4 liters. So now I can just calculate this whole thing. 10 to the 24 here, 10 to the 23 here, and I'll just put it in my calculator. And when I did that, I get a 221, so that's liters of C2H6O. Okay, find one is find the volume of this many grams. So volume of grams, so I have 71.9 grams of C2H6O. Okay, I have to have grams down here, and if grams is on one side, moles on the other. And I know that for C2H6O, it's 46.068 grams. And I'm not trying to get to moles, I want to get to volume. So I need 22.4 liters. So 1 mole is 22.4 liters. And now my problem is all set up. So I do 71.9 times 22.4 divided by 46.068. And for that, I get 34.96. 960, which I'm going to round that off to 35.0 liters of the C2H6O, assuming that that's a gas at STP. And that's the quick check.